16, very similar circumstance. You asked to solve the following triangle, which means here we're looking for angle A, angle B, and side C, which of course is the hypotenuse here. Now here, again, I could find each and every one of these things independently of each other. I don't have to use a calculation I don't have to use side C, for instance, to find out what angle A and angle B are. So these are all independent. When I start getting to non-right triangles, which we talk about more so in the next chapter, chapter 5, there are sometimes that we have no choice. We're going to have to use a previously calculated value to come up with another value. There's just no way of working around it. So right triangles, I can avoid it. But here I do know two sides of the right triangle. I'm looking for the third, so I could use the Pythagorean theorem here to figure out that C is about 12.21 feet. Now I don't have to use that 12.21 feet for any subsequent calculation, but I need to find out what angle A and angle B are as well. And here's where I use very, very carefully, because here, I'm going to introduce inverse trig functions. And of course, an inverse trig function is, when I solve an equation that has a trigonometric function in it, and I need to get rid of that trigonometric function, the inverse trig function will get rid of it. In right triangle circumstances, I don't have to be concerned about a lot of things using them. When I start dealing with situations where I have rotational angles again, the inverse trig functions do not necessarily give me all the information I need, and we'll talk more about that as we get into chapter 5, and even somewhat in chapter 6 as well. But for right triangle circumstances, I don't have to be so worried about anything. I just have to basically use it when needed. So say I want to find angle A. I'm going to use the two sides that I know, 7 feet and 10 feet. Those were given to me. Again, I'm going to avoid the 12.21 feet for the hypotenuse only because of the fact that, I don't know. That's a rounded value, and if I miscalculate anything, I would be perpetuating a mistake I made. So I don't want to do that. So I'm going to set up an equation where I have trig function of an angle equals side over side. So if I'm using 7 and 10, I'm using angle A, that's opposite leg over adjacent leg. So I'm going to be using tangent. So the tangent of A should equal 7 over 10. I want to solve this equation for A. And right now there's a tangent in front of it. Now, I'm not going to divide both sides by tangent because that makes no sense. I'm not multiplying tangent to A. I'm doing the tangent of A. Tangent is its own function, kind of like its own operation. So if I want to think of it in a manner of speaking that isn't like, the best math terminology, but again, I can put it into perspective here. I want to untangent the left-hand side and therefore also untangent the right-hand side. That'll help get A alone. And for me to do that, I'm going to apply an inverse tangent, also known as arctangent. And on the calculator, you would access this by hitting the second button or the shift button or whatever it may be, inverse button, whatever, and then hitting your tangent button. And so the measurement of angle A is going to be the arctangent of 7 over 10, which is about 34.99 degrees, which I could probably say is 35 degrees. Now, obviously, a very simple calculation would be to find angle B by saying, okay, well, angle B and angle A should add up to be 90 degrees, so angle B should be 55. But again, that's still using 35 degrees as an angle measurement, and that's an angle measurement I just calculated. So if I made a mistake, I'm going to be perpetuating a mistake if I use that to find angle B. I want to keep that in the back of my mind, though, because that might help me figure out whether or not I'm right when I get to the final answer here. But again, when I find angle B, I'm going to use only the given information again just to be on the safe side. So, I can say that, well, 55 degrees would be a pretty simple calculation for the final step. But, I want to make sure that 55 degrees is the answer I should be getting. So when I look at angle B, 10 feet is the opposite leg, 7 feet is the adjacent leg. So the tangent of B is going to be 10 over 7. And then when I apply an arctangent to both sides, again, I'm tangenting both sides, I do get that angle B is about 55.01 degrees, or about 55 degrees. So it works that way too. And since it's working two separate ways, even though one of the ways is using a previously calculated value, that kind of lends credence to the fact that it's probably right. And also, what's even more on top of that, when I look at the basic principles of triangle measurements, smallest angle is opposite smallest side, 35 degrees and 7 feet, opposite each other. The biggest side, 12.21 feet, is opposite the biggest angle, which is the right angle. Everything seems to be falling in place from that standpoint. So, because it's meeting basic principles, because in the back of my mind, I had two different ways I calculated the measurement of angle B to be 55 degrees. Everything seems to be in place here to suggest that all these are correct.